Simon Cochrane and William LeClaire, and we're here to present interactive solar systems. Basically, the project aim was to educate users on gravitational theories and rotational kinematics, and also to teach users information about different planets in the solar system. Also, we wanted to create a user-friendly program with simple controls and a simple GUI. Yeah. So the story of the project, at least for us, is we wanted to make a project that had to do with our science courses, but that would also be challenging and interesting. So I'd never worked with 3D before with Java, so it was a challenge for both of us to try to achieve that. And it actually turned out fairly well, and we're very happy with our finished product. Some of the features of the program are a customized menu, epic music, a standard solar system, procedural generated solar system, entity modification, time control, gravity simulation, planetary collisions, camera tracking, also parallax background whenever you move in the program, saving and loading 3D plane. Well, that's basically the fact that the program is in 3D, credits, and a Konami code version of the program itself. Here's the menu. Basically, if we go into the program itself, you can see you can toggle the music over here to turn it on or off. You can, if you press new game, you enter a game menu where you can start a standard simulation, a procedurally generated one, or you can return to the main menu. Press load game. You'll see different loaded saved games. You can load them, or you can, well, we'll talk about that later when we talk specifically about this menu. The option menu, where you can edit the music volume. You can turn full screen off or off again. You can change the resolution of the program. And you can return to the main menu. So yeah, set the resolution to something.
You won't do that because that screen doesn't support it.
Okay. Never mind then. And, well, credits.
We'll see later.
Yeah. So the music that plays in the program is, well, it's from a CD called The Planet's Suite. It's written by Gustav Holst. And it's basically, each song has the name of a planet. And the entire soundtrack that runs in the program is 50 minutes long, and it loops, so that if you set the music on, it'll never turn off. Okay, the standard solar system is something that Simon is going to talk about.
So when we get into the program itself, the main thing we thought of doing when we simulate a solar system is be able to recognize our solar system, the one we live in. So when we go into new game, we can just start a standard simulation where we can see all the planets that are in our solar system. So we have the sun that's right here, we can see. We have Mercury, we have Venus, the Earth, Mars, Jupiter, and far away we have Uranus and Neptune, which are all completely seeable. It's basically our solar system, and it really works. We'll show how well it works later, because what we'll show now is just that we can have a solar system, but it's kind of repetitive. We only have one solar system. So what we implemented is what we call procedural generation, which is based on a seed. So the limits are basically none, because you can generate as much solar system as you want. They will almost technically all be different. So we can directly show that from the in-game menu. We can already just start a new game. We're going to procedurally generated. So it just generated a solar system, which has a planet, just called with a random name. This is a star, and we have multiple planets. Each have a description and a name appropriate. You can change everything on it. And if we just redo it again, then it's a new system, completely different. Here we have 2 planets, which is the minimum. We can redo it. Right here we have about 10 planets, let's say. So there's really no limit to the different solar system that can be created. So the next idea we had to actually be able to visualize what is the impact of gravity, not just see planets rotating around a star and that's it. I wanted to show what's the difference. What if the sun was 10% bigger? What would happen to our solar system if, say, the sun is 10% bigger? So if I go to my standard simulation here, I can take my sun and say, make it bigger, make it bigger, make it bigger. What happens? So if I actually start a simulation, you'll see that Mercury doesn't stand a chance at all. Just straight goes into the sun. The sun's too powerful. Even Venus can't do anything, and Europe will probably be doomed as well. Mars will probably be saved up here though. But I'll save you that for later when we see details and do the gravity simulation itself. So also the idea to show you that is that you can control the time, which is the speed at which it goes, because it can go really fast. Because if we set it in real time, which is 1 second per second right here, well, as you can think, 1 second per second when simulating a solar system is really, really long. You're going to spend a year if you want to see the Earth go around the sun completely. The way we can do that in the simulation, I think, for example, a process will generate a planet. I can just start. If I go, I guess, 1 second per second, we don't see anything happening. There's actually really precise calculation happening in the world. However, it's not really interesting because we don't see anything. If I go, let's say, up to a day, and I get to a planet really close to the sun, we're going to see it working. We see it moving really slowly, but it works, it's precise. And I can get to a week, which we can see actually some precise movement, but it's fast enough. And if I go to a month, then we can go like really fast and see really good things happening. The idea also is I can in real time just modify the planet. Let's say I want to call this a planet that's going to be destroyed soon. Just change its name. Now it's going to be annihilated soon. I can change its radius. I can make it bigger. However, I changed the sun size earlier on, and that actually changed something because the sun is actually really massive and has strong gravitational pull. But a small planet like that has literally close to non-gravitational pull on any other entity. So it doesn't really change much. However, if I get greedy a bit, I can destroy everything. And everything just becomes one big planet. I'll explain later how it works. So after time control, which can actually be customized, like here we can enter the own value. Well, this is actually the maximum. It's a month per second. Because if we go much faster than that, then the precision of calculation won't be enough and some error will appear. So another interesting feature we have to add in-game is the toolbar, which is really interesting because it gives you all the tools right in the simulation without having to go back to the main menu, which is quite actually interesting. If I go to my solar system here and I say, oh, let's say I want to load a level, I can just go here and load it, or return, continue my simulation, nothing's lost. Even if I start it, load game, come back, it will pause, but it will still be there. So the idea is that you never stop from going back to the menu again, and if you're lost, because that can happen, let's say I focus on Venus and I'm like this, and then oh, where am I? I can just do view and reset my camera, which will just like show me the standard view when I click on the planet. It will be the same view, which is also quite an interesting thing. We can click on any planet and focus on them. So apart from the toolbar, which contains like the time warp, we already saw a file which can open actually any menu. The main idea behind the program is to simulate gravity and be able to show what happens if we change something in our solar system, or what happens during that solar system. So how can we show that? Actually, using the time, the calculations are actually made quite precise compared to what we see. Even if it's a week per second, there's not only one calculation that's happening per second, hundreds of calculations per second are happening. So it's really precise, and I can actually see the difference. And let's say I just upgrade the sun by 10% rather than what we did before, which was way too big. We're going to see planets start. Mercury never survives because it's too much for her. But if I go faster, you're going to see the Earth start to go in an elliptical orbit instead of a circular. You just saw Venus right there. Going really fast. When its orbit changes, because of actually the mass of the sun got really bigger, the sun got actually 20% bigger right there. So you can actually see like what's really happening. And let's say I want to get a closer view, then I can. Let's just pause it so I can. So I want to see from the Earth perspective what is happening. Just go on and see directly what's happening. So the next interesting feature is that, well, you say, if we have a solar system, then an obvious thing that can occur is a collision. But how do we represent a collision in space? So the way we do that is using the basic physical theory that like you cannot create energy or matter. Like energy and matter are just the same thing, or transformed. So the way we do it, since matter can be represented as mass, we take the mass of the two entities and we add them together to decide a new density and a new volume, so we can calculate the biggest planet. So the planet that has the more mass absorbs the other one. And that's basically the way it works, and we're going to show that about now. That's what I wanted to do. So if I go to a planet like this, and let's say I make this planet really heavy, like really, this is the maximum density you can get, and it's really, really dense. That should actually probably be a black hole. If we make it go, we're going to see every planet's going to go toward it, and because it has such a high density, its mass is the largest of the solar system, so it will absorb everything and become bigger. So it actually resizes. If it becomes too big for your actual camera position, it will resize to give you like a good view. But everything will just collide with it and emerge. Those won't actually make a big difference because of this. But one important point you can see is that the planet is actually much bigger than the sun was, than the star was in that case. The reason is, like in real life, the calculation we make use real life values, except that for representation, the distances between the planet are graphically shown 100 times smaller, and the planets are 10 times bigger. But only for graphical purposes, because otherwise we just wouldn't see anything. It wouldn't be interesting to look at it to actually see how it works. So that's why actually the planets are smaller. However, the stars, because they're actually much larger than planets, have just the right size that they're supposed to have. So another interesting feature that we added to actually like make the simulation more interesting is first the camera tracking and parallax background, which kind of work conjointly. So basically, you've probably noticed, but if I drag around to rotate around my planet, this is a single planet, it's boring, let's go to a nice solar system. I rotate, and you can actually see the background move in the back. So it's not too much, so you don't really notice it, but it actually creates an interesting effect that is just visually interesting. The camera tracking itself is just that if I click on a planet, the camera will track it. And it will just focus on that planet, and I can see from that planet's perspective. So let's say I go into a standard simulation. And what's really interesting is that I can say, oh, I want to see what happens from Earth, because that's the more realistic view we have from Earth right here. So if I just start this, I can see what's happening from here, like its perspective. And what's really interesting, you can see Mars right here, going that way. But if we can see, and Mars just actually like in the star, so that's because of the resolution actually in the planet shaking. But if we see the other planet, Mars will pass like this, and then because we turn, it will go back that way. And that's actually what we see in real life when we look at the stars and we see Mars. We don't understand. At first, the astrophysicists didn't understand because it's going that way, and then it's going back that way. What's happening? This is abnormal. And that's how they noticed that Mars was a planet at first. How it works, and it can actually be seen if we go much slower than this. So the main interesting feature to be able to really show what's happening in the effects is that we implement a fully functional saving and loading system. So the idea behind the actual procedural generation is it just generates a seed from the current time system, millis, so it just bases itself on the clock of the computer. So when I say I create a new procedurally generated, if I click on save, it will actually show me the seed of the system itself. But I can just decide to save it. Let's call it test, and then it will be saved, this exact configuration of the solar system. And if I go to my load game, test just appeared here. So I will just load it, and it's the same. But the idea is that if you have a seed, you can also share your seed with people. Like if you say, oh, I found a really interesting randomly generated solar system, so you can share it, for example, online, and say, what about over 9,000? It's an interesting seed. And I can click regenerate, and will generate that solar system, which is actually not really interesting. But if I load it again with the same seed, it's the same. It always remains the same. So you can actually share your configuration. The interesting thing is that the saving doesn't only work for the starting position. If I start it, then I can just say, okay, that's enough. I want to save it. It can be saved under its seed, which is actually like a modification because 9001 is too small to actually do like generate a full solar system. So we'll actually work with 9000 to create a bigger seed, but it remains the same if you just re-enter over 9000. 9001 to be more precise. Then I can save it and just in simulation because we already started working. And then if I go to my load game, then in simulation would appear here, and because I click save, the seed also appear. You can load it and it's right there. Another interesting fact is that we can actually see the different tests and like the power of the actual loading and saving system. So we have what we call the planet overload system, which actually loads a really large amount of planets, which is really interesting to see that it works. However, this amount of planet is really hard to handle for the system. Like the system won't generate that much planet usually because the way it works, every entity has an impact on every other entity because each planet has an impact on itself, well, not itself, but other planets also, not just a star on the planet. Which means that with that much planet, the system is not really responding well. However, the saving and loading system works pretty well and planets are still there. And that's about 45 planets. Yeah, 43 and a couple there, 45 planets. That we can actually go and see what they were. And well, this system, even though the simulation can start, it rarely finishes because like I told you, the system can handle it. But what's actually interesting is that you can see a pattern being created, which is a spiral following the golden ratio, which is what's really interesting. However, like I told you, it won't go up until the end. So in the end also, what we wanted to do is actually implement a 3D plane, because if you see all I've shown is all on the same plane. It's always like, the simulation is kind of two-dimensional. However, the whole system was designed in 3D. The reason that happens is that in real life, every entity that's round has actually a point that is more gravity intensive than other, which is why actually the planets in real life actually align with the stars and almost at the same angle. However, we created a test to actually show this, which is a 3D test. So we can see those planets going in different directions and it still works. The gravity still applies on all of them. So if I take this one, it's going, make its density much bigger, then everything's just going to go no matter where it is in the world, if it's in 3D or 2D. So the whole world can work in 3D. So if someone wants to actually make their own solar system, it is possible to make it completely in 3D, even though that's not really what happens in real life.
Okay, so the credits, they're fairly simple. Basically, just in the main menu, there's a credit button, and it shows everyone who's contributed to the project, which are actually some of you. So we have executive producers, Sandra Cochran and Claire, designers, us too, design supporters, yay, those guys, programmers, us, artists, me, and beta testers, which are a bunch of people that we had beta tested. And finally, we have the music at the back because we don't want to be sued.
Well, actually, the music has been written in the 1940s, so it's completely like right at that point. But what's really interesting is just like the Star Wars effect we created for the credit, where it just goes in and we can just see it going diagonally like this, which is really interesting. So, like to finish this presentation in beauty, we had a special tweak.
Yeah, there's the Konami code, which we implemented into the program. And basically, all you have to do is go into the main menu, press up, up, down, down, left, right, BA, and basically it'll start an Easter egg version of the solar system.
Up, down, down, left, right, BA.
Okay, so the sun. All the different planets now they have different bios, which are somewhat humorous. And there's a baby, a sun, just like the Teletubbies.
Yeah. So it's basically the standard solar system, but if you click on a planet, for example Venus, you see that Venus is actually a Doge, and you can see some funny description of the planet.
Yeah.
It's more of an Easter egg than anything. If you click, for example, on Jupiter, which is Nicolas Cage.
Yeah, and the bio is, holy shit, look at how big this planet is. Jesus Christ, wow.
So it's more of a fun fact, and it actually works. I mean, everything works. And the Doge are actually much faster than Nicolas Cage in this case.
Yeah, because Doge much fast.
And that concludes our presentation. Also, if you want, the project is fully available for download at www.dwarf.com in the project section. So it's available, you can download it and play with it and see how the solar system works.
So just as a recap of the story, the year is 2024, and virtual reality has been harnessed in the video game space. So now Survivor comes out and is set to revolutionize the way virtual reality is harnessed. And so this is where you come in as the player. You play Bob. And as Bob, you're one of the lucky owners of the game. You go out, buy it, put on your virtual reality headset, and enter the world of Free the Bob. So now we're going to connect the tablet and actually show you the game. Okay, so here you can see you're dropped into a new world. This is a new world. This is all procedurally generated. So you can see the zombies are teaming around. So everything here is randomly generated, as I said. When I created a new world, Bob was dropped into our new game. And every tree here is procedurally generated. So if I move left, move right, go up or down, then the world procedurally generates as I move along. And everything is infinite, so no matter how far I go, left or right, up or down, it's going to procedurally generate wherever I go. So essentially what you have is infinite content. So now she's going to show you the controls.
So you can actually move, you actually explore with Bob around the world. You can move left, right, or left. You can swipe up or swipe down to move from layers to layers.
So there's actually the concept of lanes here. So essentially we wanted to do something different in the 2D space. So we thought, how do we add depth to a 2D plane? So we thought, look, we could still move left and right. Then how do we add verticality to that? So we thought of adding sort of a concept of lanes. So you could go up, down, left, right. All of this is infinite, so no matter how far you go, it's going to procedurally generate that way. And if you go back, for instance, then the game is going to create from there. Okay, so now we're going to show you the main menu. So we can quit from here. Loading screen with helpful hints. And here you have the main menu. So you have the option to play. You can load your profile, create a new game, continue from an old profile. So what we're going to do now is create a new game. So you're dropped into a new world. Everything is infinitely randomly generated as before.
And to survive, you actually have a survival guide. And to access that survival guide, you go into your backpack in the top left corner. You open the survival guide, and you can see a list of tutorials and to know how to escape and recipes, because you actually have to craft stuff to survive. To know how to explore the world, you can see here what I said earlier. To move left or right, you press the button. You move up and down, you swipe up, swipe down, and to find an object in the world, you can see also how to get that. Now we're going to show you how. Also, there's a combat tutorial, because there's actually zombies in the world, and those zombies, you have to fight them in order to collect some items. Here it shows you how to fight the zombie. You start the game without any weapons or anything in your backpack, so you need to know how to fight the zombies without weapons, and that's what we're going to show you. So we're going to find the zombies. So when you encounter a zombie, there's the screen that's shown. And now we're in. And the zombie shoots earthquakes, or he launches forwards towards you. And to
dodge, essentially, like if you don't have any weapons, the only tactic in your arsenal is to jump. So for instance, if he goes towards you, you can jump over his head, and if you don't get hit, you can hit him on the head and deal damage to him. So she's dead now, unfortunately. So what we can do is, you know, start off from where we left off. And okay, so for instance, so I want to show the concept of crafting. So here, this menu tells you how to craft, but since I know how this works, I'll show it to you. So if this loads back, we go inside the crafting menu, and here we have a list of all of our items. So here you can see that, well, for the purposes of demonstration, what we did was that we gave the player basically 200 of each item, so that, well, you know, I wouldn't go around and collect all these items because it would take a long time. So for instance, if I want to craft an axe, go inside the survival guide, I can choose recipes, see, okay, well, how do I build an axe? I can take 10 wood, combine it with 5 iron, so I'll do that. So to add an item to the crafting table, what I have to do is press on it. It's going to add 1 instance of that item. I add 5 irons, and what you can see is that on the top or on the bottom here, what you have is an axe that you can craft. So if I press the crafting button, you get a confirm dialog, press yes, and if I go back into the game, Bob has an axe. Now what can I do with that axe? Well, I can press on a tree, he goes towards it, starts chopping it down. In 4 hits, a wood item pops up. So I can collect that. Go back into the crafting menu, and you can see I actually have 1 more wood item than I did before. So do you want to show them how the combat works with an axe?
So now we have a weapon, so it's going to be easier to win against the zombie. And you go back into combat again. And when you're pressing the button for melee weapons, you can actually hit the zombie when he comes towards you, or not.
The timing has to be right.
Yeah.
So now you kill
easier.
the zombie.
And when you kill a zombie, he actually drops iron, which is the object that you get when you kill a zombie. That's the only object that you get from the zombie. And also you can craft, also there are other weapons. As you've seen, there was another button that was range weapons, and you can craft a rifle with that. So we're going to see how to craft a rifle. For the rifle to actually be functional, you need a rifle and bullets, and to craft bullets you need gunpowder.
Yeah.
So first we're going to try to craft a rifle. So it's 15 woods and 10 irons. So the rifle is available. Now we're going to see how to craft gunpowder.
So gunpowder is really where your test of chemistry comes in handy. So like to craft gunpowder, for instance, you need sulfur, water, charcoal, saltpeter. So it's essentially a chemical formula which gives you the gunpowder. Charcoal, 6 sulfur, and 4 water. And then you get 12 gunpowder. With that gunpowder, what you could do is craft bullets. So 4 gunpowders and 2 irons will grant you 6 bullets. Now if you go back to fighting a zombie, what you're going to have is actually a button here that gets freed up, which you can use your rifle on.
So now it's
So
way
here the
faster.
rifle is overpowered, but I mean, you needed a lot of items to craft it. It takes a while to craft the rifle, along with the gunpowder and the bullets. So, okay. So now, I mean, everything here is procedurally generated. So I mean, I could go infinitely wherever I want, and content is created as I move along. So I could keep on chopping down trees, for instance. And so you keep on doing this, and then you wonder, well, how do I beat the game exactly? So you could go back into your survival guide, an entry named How to Escape. And inside that entry, you realize that you can build a teleporter with 40 sulfur, 120 wood, 100 iron, 40 sulfur. Okay, so 40 sulfur, 120 wood, 100 iron, and 40 saltpeter. But for the purposes of this demonstration, we made like the crafting of the teleporter a bit easier, so that I wouldn't be pressing buttons all day long. So 50 wood, followed by 40 saltpeter. Okay, so 40 sulfur. Take a while. 40 sulfur, and finally 30 iron. So now what you can see here is that I gained a teleporter on the bottom right. If I craft it, a little animation plays. Bob goes inside the teleporter, and here you essentially win the game. So you're brought back to the main menu, and here if I load back my game, what I'm going to see is that inside my crafting inventory I have a teleporter available. So yes, I have the teleporter available, and what this essentially says is that it's a token of victory. So each teleporter you gain is essentially one instance of you winning the game. Okay, so yeah, it's important to stress that all this art was made by us, and this game can run on essentially any Android tablet you want, so whichever size you have, it's going to run. The frame rate was also optimized. Yeah, apparently the HDMI cable is not very good. Snap cables. Yeah, sure. Okay, we'll switch back to the, because you can play it on PC, so we'll switch to that. Okay, so here I'll run it full screen, and this can actually show you that, well, it can run on any size display, whether it be PC or Android devices. So here I can start load, yes, the load menu. So here I have all my worlds. Here you have the timestamp when you created your world, at what time, and which number that world is. So here I can load the game. I have no items because, well, I lost all my progress. And I can continue on like this, going along. And now, so here we have the survival guide. We have everything we need. So essentially, yeah, so it works. So the reason why we put it on PC was for testing, for debugging purposes, so that we could, you know, not always port it to Android when we needed it. So really the purpose of this game, I don't know if you want to close with me, but the conclusion of this game, or the conclusion of our presentation, was that the purpose of this game was really to test the players' knowledge of chemistry and to test our own knowledge of mathematics. So here you can see that the world is created from either linear functions, cosine functions,
Constant.
yeah, constant functions. So everything here, the player walks on the ground through the use of these functions. You plug in an x value from the player, he returns a y value, he gets placed on that position.
And also the crafting formulas, we actually looked up for actual chemistry formulas. We simplified a bit some, like example for the crafting of the gunpowder, we simplified it a bit because sometimes it's harder and it's not really easy to find how to make bullets on the internet. So,
yeah, so simplified is mainstream, like obviously physics, like there's the jumping of physics, like we modified that so that it didn't exactly go to follow exactly the physics value so that it'd be more fun, obviously fun over realism. And so that's our game, that's Free the Bomb.
So it all started when Amin randomly made the teams. I ended up with Darren, but we knew how to work together already because last 2 semesters ago we were lab partners for an optics class. So we figured let's just do an application on optics because we learned that together. But you see, the problem with optics, the way it is taught, where's the here. What? Okay, sorry. Is that there's a lot of formulas, right? So, but really, to understand optics, you need to visualize what's happening. So some teachers will, you know, draw diagrams like this, but still, you know, you are a very smart class, so you understand stuff quickly, but other students have more trouble, so a diagram like this may not be sufficient. So we thought we wanted to create an application that helps users understand, have an intuitive approach to optics. So, but first we looked at what already existed on the net. So the best way to understand something is to experiment with it. We didn't come up with this first, but just put it there because it's funny. So let's just first look at what has been done before. Okay, so the applets that we wanted to show you don't work, so on the internet. Never mind. Never mind the picture also. Right. So we're trying to bring the PowerPoint again. Okay. Sorry for that. Okay, so anyway, what I wanted to show you is that the other applets that already exist are are very limited. So often you have an optics bench like this, and you can move components only on this axis. You can't rotate stuff. You can't vary the number of rays you have and stuff like this. So we thought we want to do something that allows users more freedom. And before we move on with the demo, I just want to tell you an anecdote, because you might be wondering, oh, but it's easy to understand, for instance, that when a ray of light, sorry about this. it's easy to understand that when a ray of light hits a mirror like this, you know, it goes like this. You know, we can kind of predict where it goes. But one day I was working on this, so I had this on my screen, and my little brother, I have a little brother, passed by, and he saw this, and he was like, what's this? And I told him, it's a ray hitting a mirror and reflecting. And he told me, no, it's not like this that it works. And I told him, yes, it's like this. He said, no, it's not like this, it's like this. The ray won't do this, it will go like this. And I was like, no, it's not like this. The ray will reflect at the same angle that it hit the mirror. But he didn't have, he didn't have the intuition because he didn't take physics courses yet. So he thought it was always like this, perpendicular to the mirror. So just to show you that it's not something we all know by default. So we'll now show you the application.
It's of the resolution problem. Sorry. No.
You'll change he's changing the resolution.
This is the menu of our game. So when we start the program, this is what you're going to see. These are some preview visual components that can move around just for the heck of it. You can play around. And first, we are going to go to the Learning Center. This is the Learning Center where the user can read some information on visual optics. And these information can be customized by, for example, a teacher. He can go inside the folder, learning. There's a text file where he can edit the text for his teaching purposes. And every single panel is different. So he can put more info if he wants to. And then there's a laboratory.
Show a bit of that. Just quickly show you all the components that are available. So in this section, you can just play around with the stuff that's there. So you have on the right panel what you can use. Sorry. Okay. So first, what is this black dot? It's a light source. Double click on it. You have a ray of light like this. Rotate the mouse wheel. You can just move around like this or use the directional keys. Okay, we have this. We have obstacles like walls like this. You can resize it. Just show you quickly. Mirrors. Again, you can rotate. More freedom than with the other applications that are available. Okay. You have curved mirrors. You can set the length like this, set the size, refractive zone. I'm showing you quickly because we'll show you some examples of projects later. Don't touch the cable, okay? You can set this, change this. Okay. You have lenses. Things happen. Prisms. Okay, and this is just a target. You can try to, have setups and just say, click this, turn it to divergent mirror, try to hit this. And we'll show you the levels section, and the point of the game is to you'll have like a target like this, and the point of the game is just to, try to hit it using the components that are available to you. So what you can do in there. Also, it's not restrained to this area like this, so you can move around like this, move your components and start working on this section also. And you can see there are markers on the sides here, there, So say you're far from where you were and you want to go back, just right click on a marker like this, brings the focus back to where you want to go. Okay, you can zoom out also if you want to see the big picture. Now we don't have much stuff here, so but you can have a lot of components and things. So you want to present how the menu works. In the corner here you have an icon. So if I click, what happens?
The first one is, this one is the home button. It will bring you back to the home screen. And then this one is clear also. For example, if I click it, it will clear everything for you to restart. And you can see that if I click this, it would ask you, would you like to save your progress before you leave? So we have an option for the user that is to save his progress. For example, if I type nothing, because that's what you're saving, it will load nothing.
No, I just do something.
So if this is the save icon. So if I save
Mirror.
just a mirror, you would save it, and then I clear everything, and then load. This one is the load button. Would you like to save or no? Just a mirror. It would show you what you have saved. And we have a control icon for you can read everything that is available to you to do in this section. So you can have the instructions clearly. Go back. Storyline.
So these are the levels.
Oh, yeah.
We'll just show you a couple. It's a simple game, as I told you. You can just do the first one.
Okay.
Click. So as you saw, that like the other levels were locked, so you couldn't reach to those. So that's level 1.
You have a tooltip box for the user to read to start. The first 5 levels have a tooltip box. It will tell you how, like, the basic controls and tips to clear the level, so the user can familiarize with the game. So to take the box off, you just have to fix it.
So let's see if Darren can pass the first level. Obviously, there's a mirror right there. That's what it's for. Okay, so you pass this one. So, and you can't, like, the light source is fixed, so that's why you have to use what's there. So sometimes the components are fixed, sometimes you can move them around. Okay, and if the ray hits the target but too quickly, it's no good, so you have to stay there 2 seconds. So I'll do this one. I'll do this one.
This was more complicated.
Yeah, so I know the tricks, so I'll do it. Okay, so this is a refractive zone, I haven't explained yet. So if you can change the index here, you can see I go up like this. What happens when the ray enters this zone, just move this mirror here. I can't, so my target is here, there, so I want to hit that with my ray. Just try that. So there. So if you change the index here, the ray behaves differently in there. So I'll try to place that. Put this a bit higher. There you go. Win. And so on. And you want to do this one? Okay, so we'll just bring you to a level, more advanced levels. So I'm going to do this. Put this one. Okay, so we'll just set the progress to more advanced. Run again. So now we have all of these are unlocked. So we'll go to our favorite. So I think it's level 7. This one. So you can see it gets more complex. So your ray is here. Have to hit the target at the top there. So I have no choice. I have to use the kind of path that's made by those walls. Try to, make your way to the target up there.
And these levels are programmed within our program. So we have the lab section. What we have is also an editor's mode. We can save the level we have created as a level that the user can play. So for example, this one we have created inside the lab.
Okay, this one is boring, I find. So okay, so here you can, this kind of ladder icon brings you to the level selection. Are you sure you want to leave? Yes. And then I think 11 is cool. Yes, it is. So now you have this. Have to hit the target right here. No choice. I have to pass through this. And then I know the tricks, so it looks easy. But okay, fast. Which one is cool? 13. Let's go 13. Okay, 13 is kind of like this. Not bad. Okay, so you have to make your way all the way down. But anyway, you get the idea. You can also use all the functions that you have in the lab. So zooming out like this. If this goes out of focus, you can just bring it back like this, and so on. So we have a project we want to show you. We made. You want to leave? Yes. The lab. So as we told you, you can load your projects, things that you've done before. So we'll just load one that's cool. Load. New. Example. All right. So as you can see, I just made a lot of sections like this, and we'll just go through them to show you what you can do. So first here, okay. Also, you can select components like this, dragging a square. You hold Alt key, and when the ray is selected, it lights up. So here you have a nice little setup. You can move your stuff. Of course, let's go over here. Okay, I showed this to people. It's cool. You can zoom in, admire what's happening there. You can move this, of course. Again, you can rotate. If you select more than one and rotate, they will rotate together. And you can put them divergent. See the lighting effect also on the obstacles. So let's go over here. Just to show you the lens, how it works. See, there's a lot more freedom than the applets you can find on the web. So this. And usually on the optics bench, you can only visualize rays that are perpendicular to the axis of the lens, but you see that's how a real lens would react to a ray that enters from the top like this. Let's keep on going. Let's go, say, over there. Click on the markers again. Here we have a prism. That's how it works. You can move the prism, make it smaller, bigger. That's how it interacts with rays. What do we have? This again, refractive zone. This ray is coming from this part of the screen. So again, everything is kind of a big screen that the rays can go everywhere. And this is the coolest part, so I'll just show you this. Oh, my bad. It's true, I forget myself. So, what are these dots? They're all light sources, so I'll just select all of these at once. And okay, it starts to be slower because when you use a lot of rays, that's what happens. And so here we have a divergent mirror. You can see the effects. Zoom out a bit. You can see that the lights, like on the obstacles, they add up. If you zoom in, it's also slower because of the see the lights add up here, the bottom there. So yeah, that's pretty much it. Do you want to add something? Alright, that's our application. Again, you can load your stuff. I don't know, nothing. So okay.
We have.
So how much time do we have? Does anyone want to try to pass the last level? Anyone? Come on.
Yeah, if someone wants.
I'll fail miserably.
Okay. Not bad. Here. Home? No.
So don't move the laptop.
Oh. I would have to pass level 15 and it's hard, so I'll just bring you to the last level from here. Level bonus. Okay.
So when you pass level 15, this is where you are going to get.
Wait a second.
Can rotate.
Rotate it, move the ring.
Control, hold control.
There's nothing.
Wait a second.
Sorry, move the target now.
You can move the light source, right?
Oh.
Can you move the box?
I call hacks.
You call hacks?
Wait, is there like a collision fiction glitch somewhere?
Yeah, I'll help you. It's kind of a, you want to do it?
Okay.
It's kind of a glitch that we found, so it's just funny. So
It's not really a glitch. It's the way we have implemented the collision detection. It follows your mouse. So if you drag the rays and you move it really quickly across the wall,
Alright, so mechanics, kinematics formula, Earth's gravity, and well, the Earth physics basically. It's stuff that we learn, but sometimes it can be hard to kind of imagine that. So we have the physics, okay, we have the gravity, we have the mechanics, we have the projectile motion, but explaining that can be kind of hard. So imagining this you know, the schema of friction, normal force, and weight. So we have this block, right? So you can imagine how it's like being a block, but why not be the pink block, right? Why not be and play and see how it feels like to be that block? So we give you the new physics of Olix. This game is basically uses a lot of physics concepts, and we put that in a game. We make that basically playable by anybody, and by this way we're going to be able to teach them these physics concepts. So the new physics of Olix is a two-dimensional puzzle platformer. It's based on the basic physics of laws of physics, and it has the objective of basically teaching everybody. It doesn't matter if you know physics or if you don't know physics. It has the objective to teach everyone how to master the Earth's physics and understand how it works. The game also is meant to be playable. I mean, sorry, not playable. Sorry. It's meant to be enjoyable and challenging in the same time. And as features, well, we have. Oops. Okay. So we have the Newton's first law, second law, and the third law. Basically, all the most important physics concept that we see. So the second one is basically it's gravitational force. All the equations that you see, we use it actually in the game. There's no equations or formulas that are created other than this. It's mainly what we learned in our classes. Projectile motion is basically what happens when you throw something or when the player, let's say, jumps or something like that. There's also friction and spring force that we're going to show you how it's going to look like. In each of our levels, we have multiple levels. We'll have 10 levels in total. As the player progresses through each level, it gets more and more challenging. There's more physics concepts and there's more tools to test it and see how you can beat the level. we have a score and timing system where the player will have to get, they will not have to, but they can get the bonus points by getting the scores that you're going to see when we're going to show you the game. And also, it depends on how fast you are. We're going to have a stat system that's going to basically store all those files in one place. Okay, and now we also have an object tool system. Like I told you about the score system, that's basically for a bonus score. We have platforms where you can jump on, and we also have angle platforms. And when I'm going to play it, but when Sean's going to play the game soon, we can explain what that's going to look like and what does it do. Tool objects, those are basically dividing in two. It can be either polygons, like cube and sphere, or either spring that it's going to help the player gain higher altitudes. We also have key objects to make, basically you have to get keys and polygons to unlock the gate. That's the goal of the game. And the net, well, it's basically all the polygons that are stored. Out there we have the instruction frame that you're going to see on the corner of the screen. We are going to have helpful hints, guides. We also have a soundtrack that you just heard just before, sound, and we also have a narration system that's really interesting, and it's something new that we've done. And we also have sound system. So before we go into algorithms, I want to show you this demonstration. So let's run the game. Alright, so Sean's now going to play. So this is the main menu of the game. This is our logo, and the music you're playing, it's not created by us. It's on Open Game Sound. So we have the option to go options. We can turn the sound off or on. The music. Also, we also have a stat system right here, and this is basically, it's going to show what's your lowest time, your best score for each of these levels. We have the option to reset for. Unfortunately, we don't for the screen. We don't see it 100% the buttons. It says go back and reset here.
Yeah, we made this for a larger resolution.
Yeah, exactly. The game's meant to be played in a larger resolution. So if you go back.
I just reset the scores. All the scores for each level are just stored in text files.
Exactly. So for each level, there's a file that's basically it's where it contains the number. Well, it's in milliseconds, and then it's divided into minutes, seconds, and milliseconds. So why don't you?
Here we can start a new game, continue if we have a save file, or we could choose a specific level to start from. We have 10 different levels that we created.
Yes.
But yeah.
After being mysteriously teleported to the planet Earth from the Andromeda Galaxy, Alex, the alien from the planet Enchanted, needs to get to his homeland by escaping through the mysterious chambers that he is now surrounded by. However, it is not easy for Alex to escape, having no knowledge of the Milky Way galaxy's physics.
So this is our narration system.
Alex from Andromeda needs to master the physics of the Earth and learn all its concepts in order to get out of the mysterious room. Alex only knows one thing. At the end of these rooms is the way back to his galaxy. He must get through to get back home. It will be a tough journey, but thankfully he has you to help him through.
Okay. So you have Alex that you play basically like what the narration system said. Alex is, strangely, he got teleported to, like Sean said, in the game. And he has to basically master all the Earth's gravity and all that. And so now let's start the new game and see Alex. So the Alex is right there. Okay, so Alex is in the bottom. Can you jump?
There was a game that seemed to be.
So the narration is also going on as well. And so that's our sound system. We also have our tip corner right here. Basically, it tells you what's. Yeah, we can't see it, so.
I also can't land there because it's below the ground.
Exactly. Okay. So our tip, we also have our score. Keys and map. It tells you the player what you have in the map. Since this is level 1, there's nothing basically. It's only the gates which you don't see and the player itself. So once you go to.
Can I put up the resolution and just look at it here?
Yeah. So okay, you want to change the resolution? Yeah, I know it's.
I can't play it without.
Okay, we're gonna try to, yeah. So it's only 180p. For some reason, it kind of makes it so that, because look at here, it's really small, that's why. So like we were saying, our start menu once again. We're going to start the game.
Alex, when we came through, he didn't understand how the slow worked, but he simply learned that he could left, right, and accelerate as he runs. There was a gate in the room that seemed to be the only way out. He had no choice but to go through it.
So this is our gates, and our score system, as you can hear, we can also jump, go left and right. So this is what the player knows now. It's what the narration tells the player to do. So why don't you, Sean, go to the gates and finish the level. So once the level is complete, it's going to tell you you have a new high score, you have a new best time, and you have to click so that you can continue. All right.
In this next room, Alex saw that he had to get higher, but how could he do that?
And once, okay, after the person hears, and then the moment he presses jump,
Just like that, Alex learned how to jump. He noticed something was pulling him down when he was in the air. Here, Alex learned about gravity and the projectile motion of the galaxy.
so with the narration, now the player knows what he learned about physics. So once he jumped and went to the platforms, he used projectile motion, and also it tells the player that he felt gravity on Alex. So, and in addition to that, we also have a hint system so that if the player forgot or something, and as you can see, the score system, it's going to score, the big score is basically in the level, and the total score is the overall levels. So why don't you finish this level too?
Well, notice we have like a little walking animation.
Yeah, we also have an animation. No, wait. No, don't go. Okay, go back. I meant start the game. So we also have a pause menu. We can go to menu, we can resume, and we can restart. So why don't you restart? Okay. So I just wanna, doing purpose and then fall down. Okay. So if the player falls, it's gonna tell the person, oh, you're trapped. There's no ways you can go through, so you have to restart. All right. So we finish this level. Let's go to level 3. Like I said, there's 10 levels. These are the tutorial levels, as we call. It's gonna get harder and harder. All right. So this is level 3.
When Alex landed on the end of the platform, he noticed he was slipping down and climbing out slower than normally. This is how Alex learned about friction.
So here we introduce friction. We have we have platforms. These are platforms, and what these are angle platforms, where if you go to them, it's basically going to slide, and this is how the player learns the friction. Here we also have to get keys. If you see it in the map, and if you try to go to the gates, now it's going to highlight in red, and it's going to show you what the elements that you need. Can you go on the gate, please, Sean? Thank you. Okay, so go in the gate. So it tells you that you need basically you have 1 key collected, but there's 3 keys in the map, so you need to get all of those keys so that you can finish the level. So what do you try? Okay. Good. Now get the other key. No. Okay.
I don't claim to be good at our game.
All right. So be careful, don't fall here because you're gonna have to restart. Okay. So we have a new high score. Since we never played, of course, we're gonna always have a high score. If you play it the second time, you're maybe gonna try to, beat your own score. So here, what you see is our polygon system. It can be either cube or spheres. Different shapes mean different friction, coefficient of friction. So the cube have a bigger friction, so it's a bit more harder to push. So why don't you push one?
When Alex pushed the sphere with a certain velocity, it began to move with him. This is how Alex learned about the transfer of energy.
So here we introduce the transfer of energy. This is the third Newton's third law. If the player hits a certain velocity, it's going to go with that velocity, and so it's not going to lose energy. But of course, the player will kind of slow down because if you go at a certain velocity and you push, it's going to slow down with. Okay, so now we have 2 polygons remaining. We have to put that in the gates, and as you saw, we can also slide. Push that down. Okay. And the last one. Alright, so gate is unlocked, we can now proceed. Good. So here, this is like last level of tutorial because now we have our last. This is the spring.
The spring compressed when Alex did on it. When you jump, begin the boost. Press the flags, trigger a boost. This is how Alex started out. Three forces along with potentially 10 energy.
Okay, so here the spring doesn't always do the same thing. It depends on how you scratch the spring. So push that one and just test it out. So here we want full compaction, and okay, here is a little bit, so there's not much of a jump. Here's a bit more. So it depends on how the spring compresses, and this is again 100% formulas that we learned. All right, go to this. Okay, push that one. All right, so now the gate is unlocked. We can now proceed. All right. So and let's complete with that. Alright, so this is level 6, but we're not going to play this and just going to go through the last levels, and then we're going to try to show you what happens when the level is done. So Sean, do you want to finish it, or do you want to go straight to... Alright, so... Okay, so now we went to the main menu. We can choose level, whatever level we want.
If we click continue now, we'll start from the same point.
Yeah, this is our saving system. Whenever you start a level, it's going to basically put it in a file. And even if you quit the game, you relaunch the game, it's going to press continue, it's going to basically look at the last progress, and it's going to start from the beginning of the last level. And we also have a choose level option where you can choose which level you want to play. As you see, we have 10 levels, so far we've played 5, but we don't want to, it's going to take a long time to go to level 10, so we're just going to go level 9, and then we'll do level 10. So this is the 9th level. Basically, all the player has to do is go right or left. But if the player jumps here, Joe, can you do an example? If he jumps, he's going to have to go all the way back again. So this is like...
we also changed the gravity, the force of gravity.
Exactly. Each level has its own gravity, so some have 10, some have 12, some have even lower, and you're going to see that in the last level. So here, jump and just, as you see, the gravity is way too low. The reason why we did that is because since it's the last level to the Andromeda Galaxy, so the more closer you get, the less gravity, of course, and yes, so this was the last level.
After getting out of the last gate, Alex found himself back in his homeland in the Andromeda Galaxy. He still doesn't know what could have caused this. Was it a sign or simply a strange dream? One thing is for sure, Alex has now mastered the Milky Way Galaxy's physics, and that is all that matters.
And that's the end of our game. So, next game. Alright. So we have a couple of things to talk about. How many minutes? 2 minutes. Okay. Alright, so now we just basically want to tell you what, like, basically our algorithm in a nutshell. So each object that you saw is an instance of what we call a contactable object, and that's how we kind of detect the collision. So between each object, there's a method. It depends on if it's let's say spheres with more platforms. It's going to basically be a method that checks both array lists, and that's why the time complexity is going to be n squared, but it's going to get lower and.
It's really simple. Like a detection, we just check the positions.
Yeah, we just compare
relative to each other and just if they're the same position.
It's comparable with a box collision, and each object it's how basically the detection works. If it's, let's say, a spring is detected, we'll basically implement our physics knowledge. And so you can kind of see the mouse. How do you see it? So like I said, the movement of the player in collision is based on physics. We also have an acceleration. Every time the player, the more the player wants to go right or left, the more acceleration. That's also another concept of physics. And it's going to check every milliseconds if there's a hit detection. Yes. So in conclusion, the new physics of all is a two-dimensional puzzle game that we teach everybody how to basically master, well not master, but have a most of the knowledge of our physics. And
by doing so, player will also enjoy and also learn at the same time. So thank you for listening. This was the New Physics Scholars.
Okay, hello everyone. So Jeremy, yes, as you all know us anyways. This is our project called SS Java. It's a game. It's based on a spaceship, and it's a side-scrolling game. And so our concept was to have a spaceship, and our goal is to basically implement some physics. We wanted to make it a game where people can learn about some physics, but the ultimate goal was to make it like a better game. And the goal, we needed to find a balance between like good gameplay and like realism. And so we implemented physics concepts such as gravity, such as inertia, forces, kinematics, thermodynamics, and magnetism in this game. And so basically it's as I said earlier, a side-scrolling spaceship game. So you're in space, you control the spaceship, and basically you'll come across different things which you have to get through. So I'll let Simon start the demo.
So we're going to start off with a little tour of the main menu. First button on top is play, options, high scores, level creator, credits, and exit. Easy stuff to show. We got options over here, which has music and sound. Put them both at 10. You can change them to whatever you want, and it will save in your preferences, so they'll be that way when you reopen the game. Next, high scores are the scores you have at the end of each level will save your score. And if you have a high score, it will appear on the high scoreboard. You can write whatever name you want, 3-letter names, like in the old style arcade games. And those will be saved there. Level creator will show after, and finally credits, of course. Sound we used is for free sound. We're coders. The artist was Jeremy's sister, and we used libgdx and Box2D for the physics engine and creating a game. So let's start off with the game. If you click the play button, you've got tutorial level 1. The other levels are locked until you finish level 1, and after you unlock level 2, 3, and 4, and 5. You can also load custom levels you create on the level creator with the load level button. I'll start you off with the tutorial so you can see what's going on. Don't know if we have sound, but let's see if we have sound. No sound. Playing sound is there a way to get sound on? Or you move up and down with the W and S keys. It works off of acceleration, so you won't stop instantly. It'll take a while, so it's a bit harder to control in the average game. Space rocks up ahead. In the top. For you guys, the top right corner, you have the progression through level. Right now we're 22% done the level. The tutorial's not that long. Top left corner is the score, currently 0. Right now we're going to dodge some space rocks. And in the bottom corner you have your hearts and your level of your ship. There you go, pass through the speed. Pass through the space rocks right there. Found them. Yeah, sometimes you're going to have to press space. You can fire bullets. Nice bullet firing sounds if we had a sound on, which we don't. So, blowing up some asteroids. I'll try to fix this. Is there a way? It's almost the stuff in it. Okay. So shooting, moving up and down, and hearts and bottom. I think we finished the tutorial pretty well. Yeah.
The only thing is points.
Oh yeah. At the end it shows you how to collect points, but I'm pretty sure you can understand that. So we'll skip to level 1 since we've already done this. Easy peasy. There you go. We'll play through level 1. It's a pretty short level, so you should play through one.
So like each level has like a basic tutorial at the beginning just to give you an impression of the new things that we introduce in each level. And so there's text at the bottom just to explain quickly what's in each level at the beginning.
Yeah, so we just passed enemy spaceships, they can shoot bullets at you. Planets have a gravitational field, so if I just stop pulling, it'll pull me into the planet, and I'll collide into it using some parts. Of course, you can pull yourself out of the gravitational field by moving W and S. It'll just try to screw with you while you're trying to fly your spaceship around.
And you can get health up with power-ups, so you have 4 hearts. Depending on the collision, sometimes you'll lose half a heart, a full heart, or 2 hearts even occasionally. And so this is the beginning of the first level. So the first level implements all the things we've shown so far, so space rocks, asteroids. These are points to collect from the end of the first tutorial. And the enemy spaceships that fire you. So the first level combines all these things, and the subsequent levels each add 1 new element to the levels that introduce the
the levels increase in difficulty as you go along. So this is fairly simple, very straightforward.
And so, as Simon said, there's a progress at the top. So currently we're at just about 50% of the level. So that basically just tells you how far you have to get. The goal is just to get to the end of each level and to progress. And at the end of each level, if you've completed the level, you'll be able to enter your name for a high score, as Simon did earlier. You see currently a score at the top. If you die during the level, your score will show up, but you won't be able to save it as a high score, and you have to restart the level and attempt to pass it again to move on in the game.
Out of the way. There you go. Not bad. When we get to 100%, the ship's going to slow down, start spinning. There you go. Yeah, sorry. Okay, we've unlocked level 2 once you finish that. We'll show you the beginning of each level to show you the tutorial of what we add, because every time you start a new level, it adds a new element to the game, and they eventually accumulate in the game. Here, in level 2, they introduce speed of light, this nice little blue thing. If you grab it, you start going really fast. You ignore collisions with other objects, and you kill most things that you impact with, such as little ships and asteroids. You just can't pass through planets if you don't want to destroy them. I'll show you there's a good speed of light that comes up in 2 seconds.
Yeah, so speed of lights will occur maybe once or twice max on each level, and basically they're often hard to get. Like this is the first one, but the other ones are often placed in positions that are hard to get, so it's either a gamble. So if you try to get it, it'll be worth it, but if you don't get it, it's often hard to survive afterwards. So it's a gamble, you try to get it, and it's a free pass for a little while, so it'll make much of it.
And so on. Okay. We'll skip over to the intros while the other levels, so we can show you everything. Preferences won't work, so we'll load them on files, not camps. Level 3, and here we introduce the sun. It's a big dangerous line at the bottom. Left corner you see your E level, here it's rising. Now it's in danger, and now every second you lose a heart until you leave the area of the sun. And I'm probably going to die because there's still 3 hearts damage. I'm going to die in the tutorial. Oh, so good. I guess it's just game over screen, which is, yeah, normally you can just try to escape the sun's field so you don't take too much damage. Game over screen says you died, your score, you can replay, select a new level, start, and so on. That's the sun that's introduced in the 3rd level. In level 4, it was an open dominance again. Thank you very much. Level 4 introduces the last element, which is magnetic objects. They repel your ship away from, planets will attract your ship and magnetic objects will repel you away. So if I go forward, it'll push me back. And then I'll start re-accelerating and come back towards it. If I go by the top, it pushes me away. But if I go in front, it'll push me forward really fast. These you can destroy. Unlike the sun and planets, which can't be destroyed, you can destroy magnetic objects and just blast your way through them.
And so this makes for like an interesting combination with all these elements in the level. So with these static elements, the ones that move, these don't really affect you so much, but when you come into play and combine magnetic objects and planets, which each push you in different directions, it's going to become pretty interesting and ultimately kind of challenging.
So you can push back on magnetic objects and attract them out of planets at the same time. Pretty bad. Got the power up. And yeah, this is pretty much how the game works. You pass through levels. So now we're going to show you the last big feature we implemented, which is level creator. Okay, who's going to show you that?
Yeah, so the level creator was not initially in our features ideas, but when it came to actually making the levels, we figured it'd be easiest, and basically it turned out to be a great feature, and we figured we'd implement it into our game, allowing the users to make levels. So basically the ship is a reference point, it's the start of the level, and basically gives you the basic controls. So you use the A and D keys to move your camera through the level. So again, this is just a creator. So you're moving through the level and you're able to place objects. At the bottom left corner here, you see the entities. So here you have an asteroid. You can cycle through them with X and C, so space, rock, planet, magnetic objects, enemies, and the power-ups, etc., and the points finally. So you can cycle through all the entities and go through the level. And when you want to add an entity, you press V, so it adds it. You can move it around with the arrow keys, and you can also drag it to wherever you want. And so you can add multiple entities of any type. And basically this allows you to create, build levels just as we did in the game as well. So the box will show you which entity is currently selected that you can move around. When you select an entity, if you want to get rid of it, press Z to delete it. And let's say the final element in this is the end of the level. So this line here shows where the level will end, where the ship will slow down and the menu will show up after. And so you can set that with E. So if I press E here, it'll set the end of the level here. So basically I can create like a quick level like this, just in any way. So I'll have a quick planet here. A couple enemies. Notice the nice Sims creator music. Very soothing and relaxing. Press the enemies, you'll get a health album. And finally end the level with a few coins. And I'll set the end over here. And say add asteroids as well. Okay, and so now when you press escape, this will give you the options in the creator. So you have the options to test the level, quickly test the level to see if it works, and you can go back right away to fix whatever you need to. Save the level. This will allow you to save it under any name that you want in the levels folder with all the other levels of the game. So you can give it a name, say level X, and you save it. Load level will allow you to load a level into the creator. So let's say I wanted to load. So let's say I wanted to load any level 5, which will show you just quickly after the hardest level. So you can just load any level and edit it, and as you can see, this will be quite challenging. We'll show you quickly after. But let's just say I go back to load level X I just made, and so I can test it, I can play around with it, and basically just like any other level, it plays like anything else. You can test it like this, you can modify anything that you've done in it exactly after by simply just going to the pause menu, getting the coins, and so you can just go back. If you press exit, it will return to the level creator. If you let it complete the level, it'll just be like any level and return to the level creator just like that. So yeah, that's pretty much it for the level creator. So we have just the final level. We want to show you that's probably the biggest challenge.
Yeah. So you want to try it out, or shall I do it?
Yeah, you want to try it out?
Load it up for you. That's the ones kind of fun.
Alright, good. So controls WS to move up and down, and spacebar to shoot, and you can do that.
Okay.
And press shoot.
You die.
Alright.
Is he going by
Yes.
Yeah, try going by the bottom. Get the heart up. The health up. No. Go by the top. By the bottom. Dodge the sun. Happens to be right. Dodge the sun.
Whoa!
So that's,
Oh, the.
into the
Oh, what the heck is all this?
Go by the top. I think that was the better way. Fire.
Oh God! Well, you have to level. Excuse me.
There's one thing we forgot to say. When you go close to the sun, so it's indicated there, so the ship heat is probably pretty obvious.
Not bad.
Well, pretty fun level. Thank you.
Thank you.
Hi, I'm Zachary, but I'm assuming that you know this. We're going to be presenting our project, Fitbox. So, what we're going to be showing, we're going to first talk about the story behind it, then the synthesizer part, the editor part, and then just a short demo of how to operate the program, and then a few short example songs. So first, the story. When the project happened, we had to find an idea, and I thought, like, why don't we find something that is fun and is useful? And so I was like, what's something that's fun and useful? Music. And then I also thought, what's something that could be simple to do and still interesting? And I thought of chiptune music. And chiptune music is made using old game hardware. It's actually a surprisingly active scene. There's a toy company is the Montreal community. And so I thought about the 2A03 chip, probably the most well-known chip, which was the sound chip for the NES, and is a fairly simple synthesizer. So I thought, why don't we build something based off of that? And then, even though you can like synthesize sound, you need some way to say what sounds you want to make. So then we needed an editor for that. And the logical continuation of that was model our program after this program. This program is called Family Tracker. It's the most well-known program to write music for the 2A03 chip. And it uses the tracker interface, which is split in two things. You got patterns, which are short segments of songs, and then here you can arrange the patterns into a certain order to combine the short segments into a full song. And so those were basically the starting points of our program. And so now for the features, first the synthesizer part and then the editor part. The synthesizer uses direct digital synthesis. It has it's a 3-channel square wave based synth. It has user definable amplitude envelopes, and it has oversampling implemented. And I'm going to explain what any of that means. Direct digital synthesis is the most common method for synthesizing sounds within a computer without using any external hardware, and it uses algorithms to calculate the position of the wave. And so our synth is based off square waves. Square waves are either on, off, on, off, on, off, in a very predictable pattern. And so our algorithm, we figured we'd use what we were learning in math. So our entire algorithm is based on mod logic, and with mod logic, it's fairly easy to calculate procedurally if it's on or off at any given point in time. And so it generates square waves, and we've got 3 of them at the same time. Each of them can be at different frequencies, and then we add them all together, and then that becomes the sound. For the whole amplitude envelope part, the square waves are always max volume or no volume, but that's not very interesting to have like sound blaring full volume or nothing. So what we use are envelopes, and here's an example of an envelope. This is all of this. The wave is always the same amplitude, but the envelope shapes the sound. And with that, it lets you have like fade-ins for the sound, or to cut it off, not drastically, but to have it fade out. And oversampling, with direct digital direct synthesis, you generate samples, which for an image are basically the equivalent of pixels. And the higher the sample rate, or the higher the number of pixels, the higher the resolution is. We generate at a sample rate of 44.1 kilohertz, which is standard CD quality, what most computers use by default. But to make sure things are as precise as possible, we implemented oversampling, which is generating things at a much higher sample rate. And so we get our information, we generate it at a high sample rate, and then take every so many samples and then pass that to the computer to be played. So that's the basic architecture of the synthesizer. Now for the editor part.
Yeah, so the editor, well, we made a music sequencer software that will look like a family tracker. We have many of its features. Let's start by talking about the song information panel.
It's divided into 4 main areas, and so we'll go through them one by one.
The song information panel, the arrangement, the envelope panel, and the pattern panel. So the song information panel can change the name of the song, the tempo, which means like the number of beats per minute. So
how fast the song is played. Is it played like, or is it like?
Yeah. Like a tempo. Anyway, the number of patterns and the number of envelopes. We also have play pause and stop button. The arrangement pattern. You have the order. You can add like a next order.
The plus or minus buttons, you can lengthen it or shorten it.
Yeah, exactly. And you put like the pattern you created in the order you want.
So here we'll, like in this example, we start with block 13, then 1, 2, 1, 2, 3, 4, 3, 5. And what's useful with this is that lots of songs, bits are just reused. So like verse, chorus, something like that. And so the tracker interface was developed in the 80s when memory was very low. So by just reusing the same pattern, you only have to store it once, which is very efficient.
Yeah, the envelope panel. You have a text field to select the envelope you want to modify or edit or create. And you have also the order and the amplitude of this envelope.
So for example, here it's 3330. Just going back to amplitude, say our wave will start at 3, 3, 3, and then just cut off completely. And it's made so that it loops on the last amplitude. So if it's 0, then it'll just stay off. If it's 1 to 3, you'll keep hearing it at different volumes.
The pattern panel, the text field also to select the pattern you want to edit. the channels, the note, and also the envelope you selected for the note. Yeah, with the note, you have also like the opportunity to edit it with like.
Yeah. So yeah, just for here you can see. Well, as I said, it's a 3-channel architecture. So there are 3 separate oscillators. So you've got 1, 2, 3. So you can set each note independently. And here you see the sequence of the notes. And here you see which envelopes are called. You've got a certain number of envelopes, and each envelope gives it a different shape. So here you just determine which shape you want to give to your sound.
So yeah, the other feature we have, well, it's an action-based system. We can copy and paste. You can also like copy parts of the tables and then paste it on another table. We have undo, redo, transpose up and down. So like to transpose a note.
So say here, if you were to transpose C up, then C would become C sharp, and then D, D sharp, E. And you can do that for whole blocks, which is very useful when you want to harmonize notes. So you can just, well, for example, in here, you just take all of this, copy it, paste it, transpose up or down. And yeah, just to specify the action-based system, everything you do is created and stored as an action, which is then performed. But these actions can be done, undone, and then redone, which means that basically anything you do can be undone or redone from the start of your session. So as soon as you open the program or as soon as you load a file. And speaking of loaded files.
Yeah, you can save the file also. The text file.
Yeah, we created a format for text files. Each thing, it follows a specific sequence for the data.
Unlimited amount of patterns, envelopes, and arrangement length. So you can basically make a song like for 1 hour if you want.
Yeah. Basically, as long as it doesn't run out of memory.
Yeah.
So yeah, now nap time. Hey. Okay, wait, how did that Alright, so this is the program, and then you can add 3 patterns. And so, say here, for example, I'm just going to create a short sequence that you'll probably recognize. So first we'll start by entering a note. I'll just go E5.
So E5, for those of you that like know Do, Re, Mi, Fa, Sol, La, Si, Do, E5 would be a Mi.
And 5 designates what octave it is. Yeah. So E4 is 1 octave lower than E5, which is 1 octave lower than E6. And so say if we just play this. So if we restart the program to have it output properly, oops. In one note, not like that. But then if you change the envelope, so say have it stay on for 3 and then just cut. Then if we play, and then short. And so say I copy, paste, copy pasting is nice. And then so I can just transpose down.
Using Control Shift T. which is indicated also in
Yes, here you've got new, open, save as, undo, redo, copy, paste, transpose up, transpose down. So, G5. That's where I made a mistake. And so, yeah, whatever, it's, what's that? Yeah, I've got a couple demo songs. It's, it takes a lot of time to create songs just because, I mean, writing music is hard. So we've got a few things. And the entire thing is just being generated by the program. None of it is pre-recorded. And for example here, the bass sound uses envelope 2. So you can see that the bass sound stays at 1, which means the bass doesn't completely cut off, which you can kind of hear.
It was a long song.
The other two songs are short. That's the other thing for demos. So this one is just used. You've got 3 notes playing at the same time. So just to demonstrate the use of chords. And yeah, the last thing just to try. Yeah.
Go.
So hi, my name is Chloe, as you know, and this is Philippe. We are here to present you our project, which is the ChemBox, which is a chemistry application. At start, we had to create an interdisciplinary program with some other tasks we had. And by looking at physics stuff and by looking at math stuff, we're like, we don't really want to do anything like that. So we looked at chemistry, even though me and Philip left the class last semester, or chemistry class, saying that we'll never do chemistry again, that it was the worst thing. But yeah, we decided that it was the most interesting stuff to do for us, and we had some kind of idea of how to implement the program with it, so we what is it?
So yeah, we programmed around the idea about making something interesting for the user that would surround chemistry, and so what we achieved was the ChemBox. So the objectives for this program was to make a student learning tool that was easy and accessible, so a student would just run it and there'd be questions for him to answer, so he'd get to practice his skill in various subjects of chemistry, and also see how reactions occur and get him interested in chemistry in that way. So we split our program into 3 different modes for the user, for the student that would use it to learn upon. So mass relationships, perfect gas laws, and reactions. Each mode has its own features that it implements that the student would go to learn, which is 3 different subjects. So without further ado.
The first mode is the reaction part. At first we were supposed to use 5 solvents and 5 solutes, mix them together and create reaction. But after talking to our chemistry teacher of last semester, she told us that it was really complex because not every solvent reacts with every solute. So it will have been, like, the program will have run some specific reaction, but the other one will do something nothing. So instead we look at it in another perspective, like when we went to the laboratory and we did experiments, we always had like the teacher presenting one more complex experience in front of the class. So we thought it could be a great idea to do the same principle. So we have many reaction that we can select and mix together and see what is the reaction that occurred at that time. Do you want to play it? Yeah, this is our main frame with the 3 modes, which are accessible with our 3 buttons.
So if we go to reactions.
Yeah, you can mix maybe, yeah, just go with this one first. Yeah. So the animation is created, the mixture is mixed, and reaction occur, which is some kind of GIF that is played with some kind of information that is displayed to inform the user of what is happening actually. For the next one, we can create the gallium and water.
Again?
Next. The color change for each reaction.
Animation is pretty safe.
So yeah, at this point you need to increase the temperature so the reaction occurs. So you have to put the temperature of 3 or higher. You can select. The temperature slowly increased until it reached a point where the temperature is high enough, and then the reaction occurs, and you can see the animation again with the information that is displayed.
So we have this for 8 reactions at the moment.
Can be increased as we
find the correct reaction, increase. And increase it all the time. So if we go back.
So yeah, we did the record. This is a little animation. We didn't know if we were able to the program. Yeah, so yeah, the temperature increase, the change of colors, and the animation and information display.
Alright, so the other sections of our program that are included are mass relationships and perfect gas laws. These are more learning tools, such as like the students in their homework. So we have here a tool for mass, moles, molar mass, and submit your answer. Here the program will allow you to calculate the mass and the moles according to the other fields you enter, according to a simple formula to calculate mass relationships, which in another section will show. So here the question is displayed. There are 50 different questions that the student can answer. All displayed here. You enter the fields, submit the next question. So in this occurrence, compound is 0.37. That's it's the PowerPoint. Good. So if we go to your file, we go back to the main menu, or we can access directly all 3 modes with the menu. So like we go to mass relationships.
Again, we have the question. So if we have here as mole 0.372, that's and molar mass has a mass of 150 grams. And calculate the molar mass. Oh, why is this 0? Molar mass of 408.6. 6. Submit your answer, and you are correct. Answer wrong. 9. Submit, you have made an error. So you can skip through the questions, which there are many of. And if you want to stop here and save your progress, you go on save. And if you switch around the questions, you load, come back to question 12, which is where you were last at. So you keep track of your progress in the questions. All the questions are kept in text files, so if ever teachers want to modify questions, add some, the text files need to be modifiable. If we switch to perfect gas laws, it's relatively the same concept. More fields, moles, this time there's moles, pressure, volume, temperature, gas constant, so just a little bit more complicated. More values to change. Again, there's reset values, calculate all the fields according to other fields to PV equals NRT formula, which is perfect gas law formula. And switch to your questions, save and load as the other ones. Save and question 3, and you will go back to question 5. And also go back to, so this covers the 3 main sections for students to learn. In help, there's hints and tricks, so just basic stuff. And for your answers, always round the 2 decimal places for answering the questions. You'll need a calculator, because the little calculator only calculates certain stuff, but some conversions of mass and pressures you need to do on your own to practice. And keep your article table for when you'll have to deal with molar masses that are not given.
Or from that we use for the mass relationship and the pressure. We have some fun facts that goes with all the reaction that occur in our reaction mode. And our credits, which is like the credit we use for the question, which is our last chemistry manual. And also all the images that I inspired myself because I made every image in that program with Photoshop.
So that should be shipped gas laws. So yeah, learning mode, stable progression, formulas, and conversions you have to do on your own. So difficulties that we had during this program, the main hindrance that we encountered were converting normal files into files. The files and images, converting them to accessible to applet, which is a big trouble for direct path and such, and different operating systems. Working with a Mac and a PC proved some difficulties for, they didn't work the same way for improving files and images, so different pathways for that. And working entirely in Java, not using any external libraries, proved its own challenges.
Yeah, for the animation parts.
For the animation was quite something. So conclusion, this was a great learning experience. It allowed us to, to operate, solve different types of problems and large-scale projects, how to deal with it, and how to plan out, and how to solve it.
Yeah, it was interesting to start with a plan and end up changing some stuff because it was not realistic and it couldn't be implemented in an interesting way. So we had to change some stuff, and it was really interesting to me.
Yeah, thank you.
Ladies and gentlemen, may I present to you my own integrated project for this course. Basically, what I wanted to do for this course is some kind of educational program that I thought of last December when Amin was explaining to us that our integrated project involves material from our past courses. And I thought of mechanics because I find that it would be really hard to work with calculus for a Java program, and so I decided to build this mechanics teaching tool, which I'm going to show you today. The objective was to build some kind of GUI application that's portable for anyone in the mechanics class, and it's for those who are having trouble with mechanics, especially if you're learning mechanics for the first time. You may come across some material that can be really hard to understand, and so what this program is supposed to do is to assist your learning process in mechanics. So what I have over here is, whoops.